Hello, welcome everyone. So today we are going to start Physics Optional Mechanics and let us move forward. In this course, we will cover each and every part of syllabus in majority and whatever is more important in examination. So let us have a look on syllabus first. So this is the exact syllabus from UPSC notification, and here we have to study four broader subtopics. They are mechanics of particles and mechanics of rigid bodies. Then we need to study mechanics of continuous media and special relativity. Right now we have planned that we will cover mechanics of particles at first, then we will cover special relativity, then mechanics of continuous media, and at last mechanics of rigid bodies. The reason of doing mechanics of rigid bodies at last is that it is very lengthy and much memory power is required, so we are going to do it in last so that it will be fresh in our memory. Now we are going to start with preliminary mathematics. The reason is very simple. Without mathematical tools, we cannot understand physics. And for our purpose, we need to understand coordinate system and then velocity and acceleration. But these two are not separate. We are going to study them in intermingled form or say implicit form. So Cartesian coordinates is what we all do know, okay, which are three mutually perpendicular axes, namely x, y, and z. But here we are required to study plane polar coordinate system. So we can see that here we have plane polar coordinate system, okay, where r is the vector which connects the origin to point P, and theta is the inclination of the same vector with x-axis. So when you break the component of this vector, so on x side you will get r cos theta, on y side you will get r sin theta. So this is value of x and y, and when you divide you get the value of theta with respect to y and x component. So this is what is the general breakdown. We know it right from class 11th, but now we are going to find the unit vectors. So unit vectors r cap and theta cap. So to find unit vector r cap, we are simply required to find the vector r. So vector r is nothing but x I cap plus y j cap. So x I cap is r cos theta I cap plus r sin theta j cap. And when you divide the vector by its magnitude, you actually get unit vector. So we have got cos theta I cap plus sin theta j cap. In the same manner, you will do for theta. But to get theta vector, you are required to find a rate of change of vector r with respect to theta, which is minus r sin theta I cap plus r cos theta j cap. And now you divide that with the unit vector of the magnitude of vector theta, and then the answer will be minus sin theta I cap plus cos theta j cap. So we have two very important result, that is cos theta I cap plus sin theta j cap, that is r cap, and minus sin theta I cap plus cos theta j cap, that is theta cap. If you want to verify that our result is now fine or not, it is correct or not, you should know that the angle between any two orthogonal basis vectors are always 90 degree, and here r and theta are actually basis vectors. So if you find the dot product of r cap plus and theta cap, we will actually get uh, it to be 0 because they are orthogonal, they are 90 degree to each other. So let us do it. So r theta is r cap is actually cos theta I cap plus sin theta j cap dot product with minus sin theta I cap plus cos theta j cap. When you take the dot product, you get minus cos theta sin theta I cap is actually 1 plus sin theta j cap and cos theta j cap, which is j cap 1. So you get that it is going to be 0. So this is verified. So we are going to use the same concept now again for the spherical polar coordinates. So now we are required to find the rate of change of unit vector r and rate of change of unit vector theta, which is pretty easy to find. Just you differentiate them and take out whatever we are going to have in common, and we are going to get the answers. So unit vector r cap is when differentiated, the answer is theta cap, the theta derivative theta cap. So theta derivative is nothing but the angular velocity. Okay, rate of change of theta, which in addition is also called angular velocity. Now the same thing when you will do for theta cap, you will get minus theta derivative r cap, and you can see that the rate of change of theta cap is in the direction of r cap and the rate of change of r cap is in the direction of theta cap. So this is what we meant to be orthogonal basis vectors. Now if you differentiate r, okay, you will find the velocity. So velocity is in this way, uh, simply when you differentiate that, so v is actually dr by dt, and r is actually r magnitude multiplied by r unit vector. So when you find the differentiation, you will actually get this value. Okay, so it is v is r derivative r cap plus r theta derivative theta cap. Now to get acceleration, you are again going to differentiate the velocity vector with t time, where you will get this value. Okay, in this value you are going to have the two component. The first component which is associated with r cap is called radial acceleration, and the second one is called tangential acceleration. And this is very, very important expression. If you do not remember the result, at least remember the how did we find them. Now we are going to study about spherical polar coordinates. Here our coordinates are not only r and theta but another angle psi also. Okay, and they are used to describe the position of the any point. So let us start by its introduction. So this is how the relationship in between Cartesian x, y, and z, and then spherical polar r, theta, and psi is related. So when you see, so a point P is connected to origin O by vector r, and then psi is nothing but the angle of the projection of r on x and y plane. So if I say you, then this line is nothing but it is actually r sine theta. Okay, and this will be in simply, this x will be simply r sine theta cos phi. Okay, and this along z axis it will be simply r cos theta. So we break the same thing and then we did write it here, where x is r sine theta cos phi, y is r sine theta sine phi, and z is r cos theta. And let me tell you, r is nothing but radial vector or radius vector. Theta is called co-latitude and psi is called azimuthal angle. Okay, so now again we need to find unit vectors r, theta, and psi cap. For that we will first need the vector r. So vector r is nothing but xi cap, yj cap, and zk cap. And once you find the unit vector r, you just divide it with its magnitude, you will get the unit vector r. Now we are going required to use these relations, that r is vector r, we know that, but for vector theta we are going to differentiate r with respect to theta, and for vector psi it is actually vector. Okay, for vector psi we are going to do find the differentiation of r with respect to psi, and once you find the vectors, it is very easy to find its unit vectors as well, just by dividing with their magnitude. So in doing so, you will simply get this expression. So you must remember this expression. This expression is readily used in various derivations. Okay, so here let me recite it for you. So r cap is sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap. Theta cap is simply cos theta cos phi I cap plus cos theta uh, sine phi j cap minus sine theta k cap, and psi cap is minus sine theta I cap plus cos psi actually it is going to be not psi but theta. Okay, so just let me confirm it for you. Just a moment. Just please be tuned. Just a minute. I'm searching it. Hmm. No, it is correct. Okay, there is nothing wrong here. Sorry, I was a little bit confused. It is correct. Yeah. So now you are required to find the magnitude of r, theta, and psi, which is written here. Okay, and this is purely the geometrical vector approach. You may find it at your own, but if you want to have the additional knowledge, let me tell you, study the book Mathematical Physics of any good writer. Okay, maybe H.K. Das, or the first one is H.K. Das, the second one is named Engineering Physics, and Riley, Hobson, and Benz. But for UPSC purpose, you are not required to know more than this what we have studied. Just memorize them and you are done. Now we are required to find the line element. Okay. So line element is nothing but distance between 2 points in a spherical coordinate system. So line element is r dr r cap, r d theta theta cap, and r sin theta d phi phi cap. Volume element is simply the multiplication of these all three, because volume is found by multiplying all the three vectors, orthogonal vectors. Okay, so it is r square sin theta dr d theta and d psi. Okay, and these are rarely used while integrating something in volume or finding the line element. And line element is found by using the concept of differential. But these are mathematical details we are not required to know. We are just required to memorize them. So memorize this equation and memorize this. You are done. Okay. And what you all are required to do, that if you want to study it uh, in little bit depth, although I will recommend, please don't go on such a knowledge gathering process. But if you are curious, then you can study vector algebra and vector calculus beforehand from the same book which I have recommended you. Okay, here, Mathematical Physics by H.K. Das and Riley, Hobson, and Benz. So now we are done with the mathematical physics, whatever is required in mechanics. Okay. Now we will move towards mechanics of particles, which is the first big topic. Okay. So laws of motion is what we need to study. Then momentum, energy, and angular momentum. And obviously, then we will proceed towards the conservation laws. So laws of motion simply talks about laws of inertia, and then a rate of change of momentum, which is equal to force applied externally. Okay, and for every action there is equal and opposite reaction. Okay, we all know that. I'm not going to describe this, just I'm going to describe equation of the second law of the motion, Newton's law. So F external is actually rate of change of momentum of the system. Okay, so this equation is very very useful for us, and we are going to make it a very fundamental equation of motion. Now, to understand the laws of the motion, because the momentum is written here, okay, it is rate of change of momentum. So we are going to study the momentum. So F external is actually rate of change of momentum. Now suppose there are j number of particles in that system. We have such system, and in system there could be many particles. So we have j number of particles. So on any particle, okay, the force could be either internal or external force or internal force. So for the any jth particle, okay, we may split the force in internal and external format. Okay, and this is the total force on jth particle. So it is actually the rate of change of momentum, okay, with respect to time, which is equal to F internal and F external on the same particle j. Now, for the complete system, we need to sum up each and every particle's internal force and external force. So we have used the summation sign. Now, summation of all the internal forces cancel each other, okay, because of the action and reaction pair. So F internal का सारा summation जो होगा वो zero होगा. The summation of F internal is going to be 0. Now we are left with this equation only, which finally becomes that F external is actually rate of change of momentum of the system. That is what we call the very fundamental part, and it is very, very fundamental in nature for us, and we call it equation of motion. Okay, now we are going to have a little bit understanding of center of mass. So center of mass, for that again we are recalling the force, which is the rate of change of momentum of the system, and this force is obviously external force. Now, okay, we are not going to write it each and every time, but we should know it that it is external force. Now, let us suppose the above equation applies in single particle system. So if the system is single particle, so there would be single mass, no summation sign, and R, capital R is actually a vector which we will describe very soon. So this is the force. Okay. So we could simply write that rate of change of momentum is actually mr double derivative. We know it from the fact that uh, it is a rate of change of momentum could be written as d by dt mv. Okay, and it is dy. We could take out the m outside, and it is simply dv by dt, and v is simply dr by dt. R is position vector, so you could write m is double derivative m times double derivative of r with respect to t, and this is what we call m r double dot. Okay, so this is what we have written here. So now for the systems of momentum, we could use the expression summation on the uh, mj and rj's double derivative, which is going to be m, which is the mass of the whole system. Okay, this is small mj is mass of one particle, mass of single jth particle, but this m is mass of whole system. Okay, so now what this capital R now comes, it is actually summation of mj vector rj divided by capital M, which is the mass of whole system. So this is actually what we term center of mass, and it is very, very important in mechanics. So it is center of mass, which do have actually j number of particles with total mass m. That is the mass of system. Now, if we know that when there is no external force, then our equation is rate of change of momentum is 0, and when someone's differentiation is 0, actually that quantity is constant mathematically. That means momentum of system is constant. This is what we call conservation of momentum. Ki when there is no external force, the momentum is conserved. That means it doesn't change, which means momentum of an isolated system is conserved. It doesn't change. Now we need to know something about center of mass coordinates. Like coordinates could be of two type. One is the normal coordinate, which we just refer as coordinates. Other is the coordinate which could be associated with center of mass of system. And the reason is very simple. When we associate the coordinates with center of mass of system, the calculation becomes very easy. Okay, so calculation becomes easy. So we know that Center of mass is actually in this format that we know it is sum of mass mj, then the vector position of that mass divided by the total mass. Okay, so we have used the same to write this for two body system. The body is just of two body. So now we will use the concept of vectors to specify positions of masses with respect to center of mass. So this is what we have. We have mass 1 here, we have mass 2 here. The r1 is the position vector of mass 1, r2 is the position vector of mass 2, and this r is the center of mass, because center of mass obviously will lie somewhere here and in the middle of both the masses. So now we will apply the triangle of addition to find this. Okay, so what is the triangle of addition? Triangle of law of addition is nothing but suppose that you have one vector like this, you have another vector which is like this. Okay, and what you need to know that here they have tail to head connection. This is the compulsory tail to head connection. So now if this is vector A, this is vector B, and you are going to add it, then the vector added vector, that is the result of this addition, which could be named C. So this C would be nothing but the tail of one and head of the other should be connected, and this is going to be vector C. So this is what we call triangle of addition. If you apply the same law here in this physics, so let me tell you, this is one vector r1, this is another vector capital R, which is our center of mass, and this is r1 prime, r1 prime. So if you find that, so from here if you apply the triangle of addition, so what could be the triangle of addition? So it is capital R plus r1 prime, which is equal to r1 vector. Okay, so from here we have written these two equations. Okay, so this is nothing in the other language. Let us say it is position vector of mass m1 with respect to center of mass, and the other one is position vector of mass m2 with respect to center of mass. Okay, you could see that here we have center of mass. Okay, this point is center of mass. So from here if you look at m1, okay, so this is r1 minus r, and from here if you look at m2, this is r2 minus r. This is what we have done by using just the concept of vectors, which is from class 11th. We are doing nothing new here. We are brushing up all the class 11-12 concepts which we have already done. So just be confident, just know that you can do it. Now the question is that why it is such a blessing to know something with respect to center of mass, कि हमें पता चल ही गया तो फायदा क्या होगा? तो आंसर इसका ये है, answer lies to the fact that in such an isolated system, वहां पे कोई भी एक्सटर्नल फोर्स नहीं होता, तो मोमेंटम जो होता है कांस्टेंट हो जाता है और सेंटर ऑफ मास यूनिफॉर्म वेलोसिटी से मूव करता है। और जब इतनी सिंप्लीफिकेशन हो जाती है तो इक्वेशन ऑफ मोशन हम काफी आसानी से सॉल्व कर पाते हैं। ठीक है, तो पोजीशन ऑफ सेंटर ऑफ मास विथ रिस्पेक्ट टू सेंटर ऑफ मास इटसेल्फ जो होगा जीरो होगा। आपकी वेलोसिटी खुद आपके हिसाब से क्या होगी? जीरो होगी, है ना। यू आर ऑलवेज रेस्ट विथ रिस्पेक्ट टू योरसेल्फ। In the same manner, center of mass is always at rest with respect to center of mass. So this is what we have written, that r is actually 0, and if you are going to simplify, it comes down that m1 r1 plus m2 r2 is 0, and this is going to be valid in center of mass coordinate system. So this is why it is blessing, because it is making our calculation very simple. Now we have one very important concept which we are going to cover in the next lecture, which is momentum of flow of mass and motion of rocket. UPSC has asked many questions. UPSC's favorite topic. So till now, let us stop and we will meet in the next part.